So let's start with the session. Any of one of you? Yeah.
So
Yes,
I
sir.
don't have any brief idea, but in short, I just heard about it's like freezing some of the layers and training it on a particular data. Uh,
Here, we are talking about fine tuning, where we basically fine tune our Llama model or GPT model or Gemini model for our own use case. For example, one of you said that you used RAG pipeline. So what happens in RAG? Like we attach external database and we query on that. But in fine tuning, similar to RAG, but it's slightly different from RAG. So we fine tune our in the fine tuning we update the weights we have in our transformer architecture. So so that for example you want to build a medical bot for let's say. So for that you want your LLM to be specific on related to medical data set or medical. It should answer you on the medical reports. So for that you need your model to be trained on medical data set. So for that we use fine tuning. So in full fine tuning, we majorly update all the weights of our models. For example, if we have a GPT model or we have the Llama model, we fully fine tune. And most generally in the industries, you want find full fine tuning. We generally do parameter efficient fine tuning because of the resource and the cost constraints. So what is LoRa? So let's begin with LoRa. Talk about, for example, GPT-3. So GPT-3 has around 145 billion parameters. So it's impossible to train that model fully. And because if we say if we go ahead and we need to train that model, so it will require a lot of RAM. Like we don't have the resources. We need NVIDIA 800, 800 GPUs, and a lot of costing is involved. And so we can't do full fine tuning. For that, we divide our matrix, like we divide our parameter model into smaller matrices. Like we have 135 billion parameters, so we divide it into smaller set of matrices, and by dividing into smaller set of matrices, we will have less number of parameters. So for example, you see different models coming up with different parameters. New models are coming up with more billion parameters, 30 billion, 40 billion, 80 billion. So we have by LoRa, we reduce the number of parameters so that we can efficiently tune our model on any of our domain specific tasks. And we can use it for any model, like whether it's Llama, whether it's GPT, whether it's Mistral, or whether it's Quen. So we can use any of the model and use LoRa technique on that. Leading with the QLoRa. QLoRa is just advanced version of LoRa technique. In this, we further optimize our LoRa technique and quantize our model weights to 4-bit quantization or 8-bit quantization, depending on our requirement. And in this, by quantization, we further reduce the VRAM requirement, approximately about 70 to 80% of the times. And along with the VRAM requirement, it also reduces time for training our model. So, and there's very little or less loss in accuracy by these QLoRa or LoRa techniques, but it highly reduces our cost parameters, and it also is very significant and widely used in the industry currently. So
By quantization means balancing the weights.
no. For example, if you know, in LLM, we have in transformer architecture, each of our neuron consists of weights, different weights, like 0.5 minus 0.1, it ranges that weight ranges.
For
So we convert that into 4-bit precision. For example, we have 0.35678 as one of the weight. So we quantize it to 4-bit. We just use 4 bits for that numeric representation. So it reduces the RAM requirement for storing that weight. So similarly, that is basically we quantize it to 4-bit and we store it into 4-bit precision. Proceeding ahead. So first question, like when you should use fine tuning, and when you should use, for example, you are saying one of you said about RAG. So when you should use RAG or when you should use fine tuning. For example, RAG, basically when you have the you need to query on your own documents, you have a certain set of PDFs or PPT files or Excel files, then you can use RAG for that purpose. But if you want one medical chatbot or one financial chatbot, or you want to build some chatbot in which you want a coding chatbot which codes for you, so we basically have one base. You can take any of the base model, either GPT or Llama or Mistral, and then you can use fine tuning on your data set, on your image data or your medical data, on your coding data set, and then train your model. And basically fine tuning is of multiple times, and basically for this domain specific knowledge, enhancing the domain knowledge, we generally use continual pre-training. Here I am providing some example, like for example we are fine tuning one model for financial domain. So let's say we start with llama model. We use 7 billion open source model because these models are open source. You can use any of the open source model as well. You don't need to use closed source models like GPT. You can also use the llama models which are open source. And then first and foremost thing is to create a data set. So you can create a synthetic data as well from GPT models for your fine tuning based on the requirement you have. And then you need a GPU as well. Like you can use either T4 or T100 GPU, which is available openly on Google Colab. You can use that as well for your on learn. First is the learning rate. So basically, learning rate is how much, like how fast your model learns all this new domain data, all the domain intelligence or the contextual intelligence your dataset has. So we should maintain a proper balance for the learning rate. We shouldn't either keep it like highly low or very high. And then we have the batch size, rank, and the epochs. Rank matrix is one of the major metrics which decides basically the size of your like decomposed matrices. In the LoRa, like we decompose the higher matrix. As I told you earlier, we have a higher like 145 billion parameter model. Then we divide it into smaller matrices. So we use generally we use 8 to 64 rank values in the industry wide, and we also have one more parameter which is LoRa alpha in this hyperparameters list. And this just based on my experience, just to give you some advantage, we generally keep this is a thumb rule you can say. We generally keep like the LoRa alpha value, which is basically a scaling factor, as twice of this rank value. This is decided based on multiple iterations we do, and this you can get to know once you do some experimentation.